This question asks us to use the factor theorem to show that x minus 3 is a factor of fx. Fx is this here, 3x cubed plus 5x squared minus 34x minus 24. Okay, so let's think about what we know about factors and think what this factor theorem actually would be. So we know that when we sketch a cubic, once we've factorised it and we know that x minus 3 is a factor, that means that our graph will pass through the x-axis when x is 3. We don't know much else about this graph at the moment, despite, besides the fact that it's a cubic, but it does pass through x is 3. Okay, so what does that mean? Well, if it passes through x is 3, that means that when x is 3, y would be 0. Y, if we're graphing this, would be the value of fx. So all that the factor theorem is telling us is basically something that we already knew from when we sketched quadratics right at the beginning. It's telling us that if x minus 3 is a factor, then when we do f of 3, it must equal 0. Okay, think back to your quadratics. You knew that if you were solving 0 equals x minus 3, some other factor, the solutions would be x equals 3 or minus 5. Nothing new there. You were already using the factor theorem. We just never called it the factor theorem before. Okay, so we're going to shove in x is 3 to this and show that it does equal 0. So if we do that, we're going to get 3 times 3 cubed plus 5 times 3 squared minus 34 lots of 3 minus 24. Okay, so let's work this out. 27 times 3 is 81, plus 5 times 9 is 45, plus that's going to be 102, minus 102, sorry, and minus 24. Adding our two positives together, we get 126. Our negatives together gives us minus 126. That does indeed equal 0. Therefore, x minus 3 is a factor of fx. We're just showing there that we know that the fact that it equals 0 is a good thing. That is using the factor theorem to show that x minus 3 is a factor of fx. Always show that you know what a result means. Okay? Cool. So now let's set about fully factorising this. We know that it's a factor. We may want to sketch it, but so far we only know one factor. So let's just carry on. Let's just move that so that we can still see the original function. So again, we're going to factorise this using equating coefficients. We know that one factor is x minus 3. And we know that we're going to have some quadratic for the rest of this. We're going to equate the coefficients to figure out what these a, b and c are. Remember, there's only one way to get an x cubed, x times x squared. We need to have 3x cubes, so we need to have a 3 there. Similarly, there's only one way to get a constant term, minus 3 times c. So minus 3 times positive 8 gives us minus 24. B was a slightly harder one. There will be two ways to get an x squared term or an x term. Last time we used the x squared term. This time we'll use the x term just to show that it does work. So if we use the x term, we should end up with minus 34x's. The only ways we can get x terms are x times 8, and the other way is 3 minus 3, sorry, times whatever b is. Okay, so again we can ignore the x's, everything's got an x in it. Minus 34, take away another 8, gives us minus 42, equals 3b. So our b should be minus 42 divided by 3, which is minus 14. We can now put that in. Okay, so we've got our factorised quadratic. Sorry, we've got our quadratic. Now we can factorise this fully. X minus 3, 3x squared minus 14x plus 8. Again, just using the square brackets to remind me I still need to do some work. Let's factorise this. So we're going to get x minus 3. Not an easy one, but we know it's got to have a 3x and an x. This could be 8 and 1. One of those multiplied by 3. And they would both have to be negative because I've got a positive here and a negative there. So negative 8 times 3, negative 1 times 3. No, neither of those is going to get me anywhere near a 14. So let's try 4 and 2, the only other factors of 8. So 4 times 3 gives me 12. I'll have a 2 remaining. That looks good for a 14. So we know they're both negative because they must multiply to give a positive, but add to give a negative. We need the 2 times 1 and the 3 times the 4. Okay, we've fully factorised this, so that is f of x fully factorised. We can now list the solutions if we need to. X is 3, as we knew, 2 over 3, or 4. Or if we needed to, we can now sketch it. The y-intercept of 6 times minus 4, minus 24, and then roots at 2/3, 3 and 4. And a positive cubic. Okay, so once we've done that, equated coefficients, we can find lots more information about this function.